If y equals 2 cosine x over 2, then d, or I guess it's d2y dx over dx squared equals.
So we're basically deriving it how many times?
Twice.
Twice. Now, do I have something within a fraction? In a fraction, do I have just a variable or something else with it?
Something else.
So we're looking at chain rule. So let's write out y prime is equal to. Now, what was a derivative of cosine?
Negative.
Negative. So I'm going to write negative 2, sine of the inside exactly as it is. And then we derive the inside. The derivative of 1/2 x is what? 1/2. How to write it out? Because some of you guys might kind of forget or maybe have already. Let's simplify this. This 2 out here and that divided by 2. Would that cancel each other out? So we have negative sine of x over 2. And then for the second derivative, let's go to our last simplified form.
Ms. Robert, can you pull it down, please?
Down like that?
Yeah.
Like that. All right. What is a derivative of just the sine alone?
Negative
Cosine, but we're going to carry the negative with us. So negative cosine of the x over 2. And then again, when I derive the inside, what is it? 1 over 2.
Wait, how are you getting 1 over 2x? Is it just because?
Because x over 2 has understood 1 in front.
Oh.
And that translates to that guy right there. Okay? And what is the answer to that one? A, B, C, D, E.
E.
Good. Let's go to number 11. So are we okay with this one? We're looking at chain rule. So on number 11, Ian, let's read.
If sine of x is equal to e to the power of y in the range of 0 is less than x less than pi, what is dy over dx in terms of x?
So it looks like we have to derive. Now, there's 2 ways to go about this problem. I'm going to go ahead and show you the way we would typically do it and give you another way that's going to give us the answer from the choices here. So the first way, it's not going to really work out according to the multiple choice. So derivative of sine is cosine. And then when I derive the other side, derivative of e to that is always e to that. So in this case, it's e to the power of y. What is the derivative of that power? 1. Now, when I'm deriving something without an x, we have 1 times, what was it? dy over dx. Write the 1 if you want to, but it's understood. So then if I want to make dy over dx by itself, all I need to do is divide it by e to the y. So I have dy over dx is equal to cosine of x over e to the power of y. Do I see that on our answer choices at all? No. We don't. It's a sad day. So we have another way to actually solve for this. Let's write out the original on the side over here. And this is piggybacked back into the pre-cal days. I'm going to leave a space in front because I'm thinking ahead. I want to bring the y down as not a power, but as a base number. Y'all remember what we did to cancel out the e? What was it? Natural log on both sides. And when I do my natural log on both sides, that goes away. So we have our y is equal to natural log of, well, I guess I'll put that in parentheses, sine of x. And now when I take the derivative, let's recall the natural log derivative. It's 1 over that on the bottom times the inside. So in this case, we have 1 over sine of x times the derivative of the bottom. What is the derivative of our bottom right now? Cosine of x. That's understood over 1. If I want to write this as a single trig function, I will put them as sine over cosine. And then notice that has to be, I heard it, tangent of x. And what is our, or not tangent, tangent would be sine over cosine, but if it's cosine over sine, is how many? Cotangent. So we have cotangent of x. And that choice has to be what letter on this one?
C.
C. All right. Number 12, I want you to breathe. It's going to take a lot of space for me at least. All right. Let me think where I want to spill my work. I'm gonna go ahead and white out this piece right here. Okay, what's annoying about this one is that the first term is written in terms of u, and then it's written as in terms of v, and then into the x, and then into the e. Okay? So rewriting the problem over and over is the part that's quite annoying on this problem. So let's start with the first one. We need to go ahead and find the derivative of tangent of u. What is the derivative of tangent of u? Secant squared. Secant squared of u. So let's go ahead and rewrite this into what we have so far. It says my u now is going to be replaced with this one. Do we all see that? And what was that? Actually, I kind of jumped to the final. That was silly on my end. I had to plug everything in first. So let's write out y is equal to tangent of u. And then we're going to go ahead and replace the u with what is given to us. And our u is what? So we have tangent of v minus 1 over v. But do I have something else in replace to that one? What do I have? V is equal to how many? So we're going to plug that in again. So we have tangent of natural log of x. And then we have minus 1 over the natural log of x. Okay. So are we okay with how I substituted them in by step? Yes? Okay? So then our last piece is our e. Because e is going to be just a constant or a number, let's derive this piece and see what happens and then plug it back in. Okay? So we have y prime. And I'm going to my last one over here. And the way I want to rewrite the last one is the following. Let's rewrite this guy right here. Let's write that as natural log of x to the negative 1. Because if I write that as a power, finding the derivative is easy. So we did say derivative of tangent was how many? What was it? Secant squared. And then according to our rule, this is our chain rule, we keep the inside as it is. I think I want to write out the power form. And then we derive the inside. So when I derive the inside, what is the derivative of natural log of x? 1 over x. The next one, we have another chain rule. To find the derivative of the next one, I need to multiply the power and the constant, or the coefficient, I get plus. Natural log of 1 less than that is negative 2. And if you want to put that in parentheses because it makes a lot more sense to you, go for it. And then I need to find the derivative of that inside, 1 over x. So just that piece alone was our chain rule. So at this point, we found the derivative. Now I can plug in anywhere I see an x as my e. So I have secant squared of natural log of e minus natural log of e to the negative 1 times 1 over e plus natural log of e all to the negative 2 times 1 over e. And are you writing with me?
Yeah.
Okay. So then let's see what we can plug in for the following. What do I know about natural log of e? It's 1. So I want you to write a side note for me. If natural log of e is equal to 1, we know natural log of e to the negative 1 is 1 over natural log of e. Isn't that still 1 over 1? So no matter what the power is on the natural log of e, it's forever going to be what number? 1. So let's go ahead and swap them. We know this is going to be 1. We also know this is going to be 1. So let's plug it in. We have secant squared. I got 1 minus 1 times 1 over e. And when I multiply the second 1 over e by 1, it's still 1 over e. So far, so good? Yes? So then I have secant squared of 1 minus 1 is 0. And we know when I go ahead and combine 1 plus 1 with the common denominator, that's going to give me 2 over e. So let's worry about this trig function. What's up?
Never mind.
Okay,
Wait, I'm confused.
where?
How did you get 2 over E if E equals, oh, it's natural log of E equals 1, never mind.
Okay, so let's go ahead and make our quadrant. And here we have 1 comma 0. And if you were to recall the ratio of secant, that was hypotenuse over the what? Oh. Secant is reciprocal of cosine.
Hypotenuse over adjacent.
Thank you. So we know in our quadrantal, hypotenuse is always 1. Adjacent is the x movement, and in our case, our x coordinate is 1. So we know for the secant squared of 1, that's going to give me 1 squared, which is still going to be 1. And when I solve for this, we get simply 2 over e. All right.
Could we get like 5 more minutes?